Hey guys, so a lot of people have been having problems with page 31. So it's question two of the rates functions practice, specifically part C. And this is definitely a difficult question. So I figured I would make a short video just talking about just part C to help you guys through it since I can't talk to you. All right, so the first thing to notice is that in part C, it specifically says that we're talking about time greater than 300. So this is going to be really important as we start looking at what exactly they're asking. So it says for t is greater than 300, what is the first time that there are no people in line for the escalator? Which means the amount of people we're talking about is definitely zero. So for part B, um, you should have gotten that there were 80 people in line at t equals 300. That's going to be useful for part C here because here it says we want to start at 300 seconds then, right? If we're talking about t greater than 300, then it means we're starting at t equals 300. All right, so we're going to start at t equals 300, which means our starting amount, our initial amount is actually 80. So I'm going to start actually by writing amount equals 80, because that's our initial, plus we're going to need the integral starting at 300 to t of whatever the rate in is, minus the integral from 300 to t of the rate out. So now we need to figure out what type of equation we can actually set up with this. So if we look all the way back up at the top, it tells us that the people getting on the escalator when t is greater than or equal to 300 is actually 0, which means no more people are getting on the escalator. So this whole part here is actually unnecessary. We don't really need it. So we're really just going to look at the amount of people is 0, and we're going to do 80 minus the integral from 300, because again, that's where we're starting, to t, because that's what we're solving for, of the rate out. Well, people are leaving the line zero point 0.7 person per second. So this is going to be 0.7, and I'm going to call it dx. We can't use t because we already used a t up here. So this is actually just the setup of the problem. And I know that there is not a lot of space here, so I'm actually going to go to a separate piece of paper now to actually solve it so that I can show you each step. But hopefully that makes sense. The amount of people is 0. We're starting with 80 people in line at 300 seconds, and people are leaving the line, so we're subtracting at zero point 0.7 person per second. And we're not adding any more people. Okay, so this is just the setup of it. So now I'm going to go ahead and go to a separate piece of paper so that we can solve this. So let's see, 0 equals 80 minus the integral of 300 to t of 0.7 dx. Okay, so let's actually look at solving this then. So the unknown here is this t. That's what we're actually looking for. So the weird part here is that you guys are going to have to actually evaluate this integral. All right, so we're going to do 0 equals 80 minus, and we're going to just leave that part alone. And now we're going to have to actually figure out the integral from 300 to t of zero point 0.7 dx. Well, that means take the antiderivative. So the antiderivative is 0.7x plus c, and we're going to evaluate from 300 to t. So then if I keep simplifying there, evaluating means plug in the upper bound, subtract, and plug in the lower bound. So 0.7 t plus c minus 0.7 times 300 plus c. And this is a calculator question, so you can use your calculator to do zero point 0.7 times 300 if you need to. So we've got 80 minus 0.7 t. We know the c's are going to cancel. This will be minus zero point 0.7 times 300 is 210. And then we can distribute the negative sign, so 0 equals 80 minus 0.7 t plus 210. If I move the point 0.7t over, I get 0.7t equals 290, and then I can just divide by that point 0.7. And so that's how we get, what is it, I have to look, sorry, 414.286 seconds. So again, part of the problem was there just wasn't enough space on the worksheet for me to actually show you all of that work. And the other part was that this is really something new. We haven't really had to do something like this before, where we had to actually evaluate the integral with a number and a variable and then solve for that variable. So hopefully that makes sense. That's how you work through question 2C on page 31 from the rate functions practice.